So today we're just covering this one spread, which is 11.4, which is not a big spread. And it's even less of a big spread because actually you don't need to know every single bit of content in this spread. And I'll explain what I mean by that. So this spread looks at issues in health services. And what that basically means is we're talking about a few different kinds of changes or developments in technology that have now led us to be able to, develop new, for example, treatments for particular diseases, new ways of achieving certain health purposes and certain health goals. Okay, so that's the basic idea. So what we're doing and why the name of this spread is not, new developments in the technology of health, and why the name of the spread is issues in health services, is that we're going to be covering each of these, but we're also going to more so look at them with a critical eye, or look at them in terms of what are the issues with something like IVF, what are the issues with nanotechnology, what are the issues with stem cells. So we're focusing more on the limitations. For this reason, we're not going to ask you to get into the whole biological explanation of what stem cells are, for example, but it's more so what's wrong with stem cells. Even though stem cells are indicating or are evidence of the fact that, our health technologies are developing and all this kind of stuff, why are stem cells an issue, or why is it problematic? So we're basically looking at the limitations. In other words, we're kind of evaluating these different health services. Okay, and all of these health services are obviously made possible because of the advancements in technology. For example, 50 years ago, we wouldn't, people who can't get pregnant wouldn't be able to use something like IVF. Okay, if you lose a limb, you wouldn't be able to get a new limb printed out using 3D printing. So all of these things are only possible because of the modern day progression and the modern day advancement of technology that we experience in our world today. Okay. What did I mean when I said that you only need to learn, you don't need to know everything? What I meant is that for the SAC and for the exam with this spread, you only need to learn any one that you would like or that you're most interested in. So for example, as we go through these topics, if 3D printing of body parts is something that really interests you, you might actually choose to just learn that one. Okay. On the other hand, if artificial intelligence and robotics and how robots can promote our health and well-being and achieve different health purposes, if that interests you, you might choose to only learn that one for the SAC and for the exam. You can learn the same one for both the SAC and exam. You don't have to mix it up or change it up if you don't want to. Okay, that's the basic idea of today. So what we are going to do today, I am going to go through all of them with you, but it's up to you to decide which one you want to study in depth. So maybe just make a little note somewhere, choose one from 11.4 to study for SAC and exam. So you remember, and you're not wasting your time studying all of them. Okay, so having said that, let's just get straight into the different types. Now, I've already talked about what issues are kind of evident as health services progress and advance. Basically, this idea that sometimes when we're talking about, sorry, I don't know why this, okay, I don't know why the font's gone that way. Let me fix that. Otherwise, it's going to annoy me the whole time. That's better. Okay, so what are the issues as health services progress and advance? So basically, even though we live in a world today where we've got so much technology, and in many ways, we are so blessed compared to previous generations, right? We've got all this technology, at the click of a button, we've got everything that we need, even in terms of what's available. Okay, a lot of people, for example, get suspicious and get very skeptical of the COVID vaccine, like, oh, many vaccines in the past took 20, 30 years to develop. How did the COVID vaccine develop so quickly? Well, one reason we could argue is because of the current kind of progression of technology, the fact that technology has come a very far way from even the 1990s or even the 2000s, okay, which don't seem like they were very far away, in terms of time. But if you think about it, that's 20, 30 years back. So technology has come a really far away from when you were just children or from when you were just in kindergarten, for example, okay? Technology has developed. Now, even though that's a good thing, there are certain issues that come up as a result of technology and these health services progressing and advancing, okay? The first thing that comes up is the concept of ethics. Now, those of you who do psychology or even sociology, you might have studied about ethics, okay? Ethics is basically this idea about what is right versus what is wrong, okay? Some people, for example, not everyone in society, for example, would agree with something like IVF. Some people might say, oh, it's not natural, oh, it's not this, oh, it's not that. Okay, so that's the idea. Some people might not believe with 3D printing of body parts. Some people might be like, oh, that's fake, it's not real. It's not like getting an actual transplant of a body part or an actual implant of a body part. Okay, so some people might not believe with these, or for some people, these things might actually be wrong. Okay, unnatural, unreal. Okay, as a society, we have to remember that we've got people of all different cultural backgrounds. We've got people of all different religious beliefs. We've got people who just have general different values and different beliefs in general. Okay, it's not even just about culture and religion. It's about who you are as a person as well. Okay, and basically ethics comes into play with advancements in technology because of this idea that, and I'll put it down here because it could be a motto for the rest of our thing, people are afraid of change. Okay, that's the basic idea. If you're so used to going to, for example, the doctor for face-to-face appointments, you might not be as open to the idea of telehealth. For example, my parents, yeah, they do telehealth and they, call up the doctor now. But in the beginning, they were very skeptical about it. It wasn't something they just wanted to do very readily. Okay, it was something that they were like, oh, will the doctor actually call me back? Like, is it actually going to be like, proper? Is it going to be organized? Blah, blah, blah. Once they realized how effective it was, though, they were happy to continue doing it that way. Okay. So we have to remember, though, that when we're talking about the health services progressing and advancing, it's this idea of what you see as right versus wrong. It's as simple as that. But we also need to understand that there are other barriers to healthcare. Okay, and to accessing these health services. In general, some of the barriers that are associated with all the different things we're going to go through today, they might not be available to all people. Okay, could be due to factors like you living very far away in a rural or remote area. We know those areas don't even have basic hospitals, let alone high-tech facilities. Okay, we know that sometimes cost plays a role. Okay, some of these new technologies are way too expensive. We can say, oh yeah, I can get a 3D body printing of a body part, but do you know how much that's going to cost you? It's going to be a lot of money. Some people can't afford that, especially if you're on a low kind of SES income bracket there. Other factors such as sexuality can also play a role. So sometimes, depending on what you identify as, you might not be able to access certain treatments, or some treatments might not be available or kind of eligible for you. Okay, equity of access is about trying to make sure that regardless of whether you live in a rural or remote area, whether you have a low income, what your cultural background is, people are still able to access these newer technologies. Okay. Some of these procedures can be invasive, especially things like nanotechnology, which we'll look at, because they need, you need to like make an incision, or you need to insert some kind of instrument into the person. Okay, for that reason, some people might be very kind of irky about these particular treatments there. Okay, so that's important. Also, we need to understand that even if we have these limitations, people still have this idea of freedom of choice. So just because a new technology is there in your society, just because, people are 3D printing body parts rather than having like actual heart transplants or stuff like that, it doesn't mean you have to get on board with it as well. Okay, again, some people are afraid of change, but change, and whether you're ready or not to step up to the change, is influenced by so many different factors. So it's not like you have to be forced into adopting new technologies, okay? Particularly when something like your health is on the line, okay? So that's the idea. Or some general issues or some general kind of limitations of all of the different treatments we're going to look at today. Okay, now the first one is IVF. Now, IVF is this general process of fertilization or of conception, where rather than, sometimes it doesn't happen naturally. For some people, there are multiple health issues that can lead to a couple not being able to conceive successfully. Okay. In this case, if a couple still wants a child, they can actually use a process called IVF. IVF is kind of the manual combination or the manual fertilization of an egg and sperm. It's done in a lab. And so for that reason, sometimes the babies that are born through IVF are also called test tube babies. Okay. It's not as simplistic as that, but that's the general kind of nickname you might have heard of. IVF is recommended for healthy heterosexual couples. Again, only kind of straight couples can access this. So again, talking about this idea that depending on your sexuality, sometimes some of these treatments are not accessible. Okay. And generally you can only be eligible for IVF if you've already tried to conceive a baby naturally for about a year and it still hasn't kind of happened. Okay. And that's usually due to reproductive problems, either on, on the husband's side or on the wife's side, or any other health related issues or problems. Okay. So obviously you can't go in like 2 weeks after you're trying to have a baby, you're like, oh, can I have IVF? They won't let you. You won't be eligible. Okay. So that's the basic idea. IVF can be used by single women, but then you'd need to get the egg from another male. So it would that's a whole other process. Some ethical issues, though, that can arise from IVF, and this is kind of the important thing that we need to remember. And number one, IVF treatment is very expensive, okay? An average cycle of IVF costs about $5,000, which is a lot of money. And, if you're low SES, you can't really access IVF. You just can't afford it. Look, you're struggling to put money on the table. Where are you going to have money for IVF? Okay, so that's the idea. Another issue or another limitation or disadvantage of IVF, or another we could say drawback, is that IVF allows older people to have babies. Now you might be like, what's the big deal? Why can't, an old person have a baby? It's not an issue, but some people in society thinks it's wrong. Because look, if you're 60 years old and you've had a baby through IVF, you're not going to live very long statistically after that child is born. When that child is 20 or finishing school, you'll be almost 80 years old. You might not even be 80. You might not be living anymore. Do you know what I mean? So that's the basic idea. When we're talking about IVF, it does allow older people to have babies, but there's not really a gap or a limit at which that's reached. And we can't really discriminate and say, oh, you're 50 years old, you can't have IVF, you're too old, get out of here. It's not fair. So it's kind of like a very fine line we have to draw. Okay, in terms of the actual process as well, during a single cycle of IVF or an average cycle, about, it's not just one embryo that gets created, it's many different embryos, okay, that get created. And so technically, those unused embryos, or the embryos that are not actually used to conceive the baby, need to be destroyed. So what you're kind of doing is you're kind of killing or destroying, embryos that could have actually become babies at the end of the day, but because we've already got the successful embryo, we don't need that anymore. Okay, so that's the idea. Another issue with IVF is, just like humans try to destroy everything, they also try to destroy the process of IVF, saying, oh, we want our baby to have blue eyes. We want our baby to have, not have any kind of physical disability. And so when you really play too much with genetics and try to create what are called designer babies, there are a lot of ethical issues that can come up as a result of this as well. Okay, so that's IVF. Okay, that's all you need to know. You don't need to go further into the biology of it. You just mainly need to focus on these points that I put a star next to. Okay, know the definition and then just know the points that I put a star next to. Okay, so let's move on to the next one. And if you have any questions about any of these, just feel free to let me know, or you can even email me later on as well. Okay, the next one is nanotechnology. Nanotechnology is basically just like the word nano. Okay, if we think of the word nano means something that's really, 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 really small. Okay, nanotechnology is about minimizing or making the size and scale of health services, medicine delivery as small as possible. That's the basic idea. And by small is actually an exaggeration. We're talking about like microscopic. We're talking about even smaller than microscopic, okay, as small as possible. I'll give you guys some examples. For example, in current day, when we want to diagnose certain diseases like HIV or cancer, we actually need to we need to go through extensive testing. We need to go through many blood tests. But with nanotechnology, we can actually engage in this healthcare on a really small kind of very, very small scale, okay, where we just need one drop of blood from that person, and that one drop of blood can be used to determine whether that person is positive for HIV or whether that person is positive for cancer, or which stage of cancer that they're in if they are positive. Okay, so just one drop of blood. So it's as small scale as possible, but it's giving us the same information that would otherwise require multiple tests or multiple methods to obtain. Okay, nanotechnology can also help us to administer medications and drugs, or deliver those medications. For example, in a world where nanotechnology is the main focus, we can actually deliver vaccinations without the use of an injection, which is what we see today. We have to obviously get injected, but in the future, where nanotechnology becomes more and more commonplace, vaccinations can actually be delivered without having to use an injection. Okay, nanotechnology is very much responsible for a lot of operations. For example, a lot of people get their appendix removed at some point or the other. And the old operation for getting the appendix removed was that they actually cut open your stomach, and it's like an actual big scar, okay, on your stomach. But now what they do is that they actually just have to make a tiny little hole, and they're able to destroy or remove the appendix using a laser. Okay, which is showing you they're trying to make that process as small as possible, or as kind of streamlined as possible, compared to doing it on a larger scale. Okay, that's another example. There are some disadvantages though, so I'll just put a star on these two. These are the ethical issues or the ethical concerns with using nanotechnology. Number one, there are significant costs that are involved with actually developing these particular kind of nanotechnology based treatments. Okay, it's very expensive, and that kind of explains also why it's taking so long for us to come into a world where vaccinations can be delivered without injections. I mean, it doesn't look like it's going to happen anytime soon, and that one of the reasons is it's very, very expensive compared to just using the traditional method. Also, another ethical issue with nanotechnology is that some people, like I said before, people don't like change. And when people think about, we have to, move away from the traditional lens of medicine, we have to, how can I know for sure that a vaccination has been delivered if I don't see an injection? Okay, so some people are not very progressive in terms of healthcare, and they might not be happy with something like nanotechnology, or they might not believe that it's actually real or that it's actually correct. Others might worry about the safety of the procedures involved as well. Okay, even though one of the main plus points or advantages of nanotechnology is to streamline and to make everything easier and safer. Okay, that's the basic idea. So you just need to know, any two of these limitations there for nanotechnology. When we're talking about artificial intelligence and robotics, I'm pretty sure most of you know what artificial intelligence is, but it's kind of like using robotics and basically infusing or kind of embedding human intelligence or the way humans think into robots. Okay, and we see this every day. We see this in our like our assistant things like Siri or Google Cortana, all these things where they are able to use human intelligence to answer your questions, use human intelligence to kind of say, okay, you said this, did you mean this? So they're able to kind of make those kinds of decisions and make those kinds of judgments based on what you input into them. So similarly, for artificial intelligence and robotics, people are kind of bringing up these ideas that in the future, just like our checkouts at Coles and Woolies ended up getting replaced by self-checkouts, in the future maybe we can also replace doctors with robot doctors. Okay, that's the basic idea. Considering that AI machines and robots have this ability to read extremely vast amounts of information. They're robots at the end of the day. Data collection, data analysis is what they do. And so some people, especially people who are proponents or who are supporters of artificial intelligence and robotics, what they say is, with robots, they can't go wrong. They've got the information and they're able to make a really quick and informed diagnosis there. That's faster than maybe a traditional doctor's diagnosis. So that's the basic idea. One of the ethical concerns with using AI and robotics is that we've got this issue of privacy. Just like self-checkouts can be hacked, okay, which they can. Just like your phone can be hacked, just like your computer can be hacked, or your ISP address can be hacked. All of these things are based on technology, okay? But if, for example, someone was to hack an artificial intelligence linked to a big hospital, or a robot doctor, okay, a doctor that's, you know, a robotic doctor, okay, if these were to be hacked and your personal private health information and health records were leaked, that would be all over, you know, all over the internet. Companies might be buying that for money, okay? And so then that idea of privacy and confidentiality kind of goes out the window. So that's the main issue with AI and robotics. Okay, so the next one, so hopefully that makes sense. Again, you don't have to go into super technological or biological depth with any of the technologies here. Just need to know the definition and just know kind of like the disadvantages, or why this particular technological advancement becomes an issue, because that's the name of the spread, issues in health services. Okay, the next one that we're looking at is 3D printing of body parts. So 3D printing of body parts is actually already quite progressive. It's already something that they are trialing in many countries and in many hospitals. Okay, most 3D printing of body parts today is done for bones and hard tissue. Soft tissue, for example, a 3D printed body part like a heart or a lung, it's still in the process. But hard tissue is there. For example, if you break a bone, you can get that part of the bone 3D printed. Bones can be printed from very hard material like titanium, okay, which is already used in surgical implants. So it's already safe to be put inside the body. It's not like it's a new substance that we've never used before. So that's the basic kind of definition of what a 3D printed body part is. A 3D printing body part, if you've ever looked at a 3D printing machine, it's just you put a mold or you put a little diagrammatic representation of what you want, and then it just 3D prints it for you using that 3D kind of printing wire or material there. Okay. Generally, one of the main concerns that we talk about when we talk about 3D printing of body parts is that it is, again, very expensive, very pricey. So not all people can access it. Okay, if I'm from a low income or low socioeconomic status bracket and I've broken my bone, I can't rely on 3D printing of body parts to get me a new bone or to fix that bone for me. Okay, because it is extremely expensive. Okay, but on top of this, people who live in remote areas or rural areas of Australia, they are not able to access 3D printing of body parts, because usually 3D printing of body parts is something that's majorly conducted by hospitals and medical staff. Okay. And you know, if you don't have a normal hospital or a normal medical center in the remote area of Australia in which you live, what are the chances that you're going to have a facility or a 3D printer to do that for you? Okay, so that's the basic idea. And that's one of the main issues with 3D printing of body parts. Okay, and stem cells. So when we look at stem cells is, if you do biology, you might have learned about it as well. It's basically, it's an ever-growing domain of biological research, where basically we can actually create certain types of cells to regenerate. For example, in current day, we know that certain cells don't really regenerate, okay? Or that sometimes if you've got, for example, a damaged liver because of alcohol consumption, those cells in your liver go through cirrhosis, where they basically die out, okay? If we were to have stem cells, what we could actually do is we could actually create extra cells that we can then put into the liver then, okay, or that can grow in the liver and can kind of regenerate that liver, or regenerate or replace that organ that basically has been damaged. So stem cells are an unspecialized cell, which means that they start off just kind of very generic, not having a specialization as of yet, but then we are able to differentiate them into specific cell types. Okay, so that's the basic idea with stem cells. So when we're talking about some of the issues in terms of stem cells, number one, there's this issue about destroying human embryos. So for example, sorry, no, this is wrong. Why is this point in here? Okay, that's weird. All right, no, when we're talking about stem cells, we're basically talking about this idea that not everyone can access stem cells. And what that means is that stem cells are quite expensive. Okay, we can't just ask someone that, oh, one part of my heart, is damaged, or one part of my heart is, has a tumor in it, or one part of my brain has a tumor in it. Can you create new cells for this? Not everyone can afford that. Okay, even though that technology is there, the accessibility is not there. So that becomes an issue. Also, the same kind of issues we talked about before, that when we're talking about rural and remote areas, people can't actually access, access stem cell research, or access the ability to regenerate or to create these stem cells in rural or remote areas. And so that can become an issue as well. So the basic idea that we need to remember is that whenever we're talking about stem cells and we're talking about the implantation of stem cells into an embryo, okay, maybe to avoid, if early on it's seen that this child has, for example, this child is likely to be born with a heart-related issue or a hole in the heart or something like that, we can obviously use stem cells to make sure that their heart, by the time they're born, that their heart is fully developed and fully working, and that there's no hole there. But that is going to be very expensive for us to do. And that's the main issue, okay, when we're talking about the use of stem cells, okay? So it's really important to remember that whenever we use stem cells, we need to understand that stem cells are not always 100% successful in terms of success rate, and that also you're putting a lot of money into something that might not necessarily be very successful for you or for the purpose that you want to use it for. Okay, so that's the basic idea. However, for small purposes, like for example, for replacing specific damaged cells in specific parts of the body, for treating diseases like diabetes, for example, to strengthen the pancreas so that it can, secrete insulin properly, all those kinds of things can be done using stem cells. So that's where stem cells can be useful for us. Okay, so that's the basic idea. So you notice, guys, when we're going through these different kind of developments or kind of advancements in technology, whether it's stem cells, 3D printing of body parts, robotics and AI, nanotechnology, or IVF, they've all got very similar kind of disadvantages or limitations. Okay, most of them talk about issues with costs. Most of them are very expensive. Most of them talk about issues with accessibility in terms of, can a person afford it, but also in terms of, is it available where a person lives? Okay, we know that usually in rural and remote areas, not all of these services are available there. And on top of that, because these are up and coming and new technologies, we don't really know how safe they are. Okay, even though there might be a lot of research done, we don't really know how safe they are or how successful they are as well. Again, this is why the first slide is very important here, because it kind of lists out all the general issues with each of these kind of advancements or developments in digital technology, okay, that we talk about. So that's the basic idea. Okay, so I'll just pause the recording or stop the recording here because we are done for this spread.